Good morning, everybody. Today we're studying the remainder of last week's lesson. So we're doing module 6.4, which is linear inequalities in two variables. All right, that's what we're starting out with. We are also doing, a little later, we will be moving on to module 7, 1 to 73, all right? So we're going to be doing module 7.1 through module, all right, so we're doing modules, just modules, these submodules 7.1, 7.2, and 7.3. And these are basically dealing with, they're dealing with polynomials, all right? So what we're doing today is we're going to be doing polynomials. All right, so that's going to be for later. So we're not doing this just right now. This is just for you to know what the goal is for the day. This is for later. It's not something we're doing right now. All right. So in a way, we want to start out with this one. We want to start out with the linear inequalities in two variables. All right. So linear inequalities in two variables. That's where we're starting out, right? All right, so here we are starting out with the classwork problems, and at hand we're going to be looking on classwork problem 13. You're going to be responsible for that on your version of that problem. All right, and so here we have, we are graphing. You're asked to graph this right here, graph the inequality. And so to graph the inequality, what you're gonna do, steps are very simple. What you need to do is you need to get yourself a line. To get yourself a line first before you can draw the inequality. So what you need to do is you need to get yourself a set of coordinates. So you use the border. So this is the border of the inequality. So the border of the inequality is y is equal to 1/2 x plus 2. 1/2 x plus 2. That's the border of your inequality. Okay, the border of your inequality is 1/2 x plus 2. All right? So let me get my camera to pick up what's going on with that. So we're doing 1/2 x plus 2. And so for our border, again, that's a border. All right. And so you can get these set of points here, x and y. So we're looking at x values and y values, as you can see there. All right, so let's just say pick the easiest value that we know. Let's pick multiples of 2. So let's say -2. 1/2 of -2 is going to be -1. All right, so 1/2 of -2 is going to be -1, and then you're going to add 2, and you're going to get 1. But anyway, let's just do it. So it's going to be 1/2 of -2, and then you add 2 to that, and you are going to end up getting, when you do that, you're going to end up getting 1. All right, so that means that -2, 1 is going to be on the graph. Let's pick another value, 0. So 1/2 of 0, 1/2 of 0, 1/2 of 0 plus 2 is just going to give us 2. All right, and then you're gonna, let's say, pick 2 again. So 1/2 of 2, 1/2 of 2 plus 2, put that in your calculator, you're gonna get 3, right? And this is not hard to do, all right? And so what you're gonna do now is you need to have these particular set of coordinates. So you're gonna have -2 for the x and 1 for the y. Then you're gonna have 0 for the x, and you're gonna have 2 for the y, and then you're gonna have 2 for the x and 3 for the y. And so you got these pairs of points, all right? You got these pairs of points. And so what you're gonna do now is you are going to take those points and you're gonna plot them, all right? So you're gonna take those points and you're gonna plot them. And so what we have here is we have a Lumen ohm graphing mechanism. That's what we're gonna do now. So you're gonna use your Lumen ohm graphing mechanism. So I'm gonna go to Lumen ohm. I'm on Lumen ohm already. Again, this is number 23. Okay, so I'm just going to erase this here. And so I'm gonna look on, look for my pick a line now. The kind of line this is gonna be a dotted line. All right, so this is gonna be a dotted line. Why? Because of this inequality. So when you don't have that, when you have the strict inequality, right? So you see that strict inequality here, there's no second dash underneath, there's no dash, there's no bar under here. So that's a strict inequality. So that's gonna give you a dotted line. All right, and so we're gonna get the dotted line here. All right, so, all right. So I'm going to take the graphing mechanism that I have. I need to take this because I need the dotted line. And what I'm going to do is I'm going to make sure that I get my points that I discussed before. -2, 1. So I have -2, 1 is one of my points. The graph also goes through 0, 2. And I really only need 2 points. 2 points to find a line. Now, there's a little problem here, so I need to clear that. This is what I chose. I do not know why Lumen is not doing that. So -2, 1, perfect, awesome. And then 0, 2, perfect. And now I want to find out where to shade the inequality. So the inequality says less than, right? It says less than. I don't need this point here. It's gonna, okay, so what's gonna happen now? Let me see something. This is a Lumen ohm problem. You can see what's happening, right? It really is challenging to use the software. So -2, 1, and then 0, 2. And then now I'm just gonna shade. Awesome, so now I have it shaded. All right, and let me just pick some point here. Okay, so I shaded. All right, and so why do I shade below? Well, if you go back to what we just had, let's go back to the set of values we had. Actually, let's go back to our original problem. All right, it says less than. It says less than, so if you're less than, that means you're shading below. But there's another reason that I actually want you to think about. Why do you shade below? Well, you shade below because you can pick any point that you want to test. So I'm going to test the point 1, 1. All right, I'm going to test the point 1, 1. So let's see if 1, 1 should be in the shaded region, right? So I'm trying to see if 1, 1 should be in the shaded region. Well, if x is equal to, if y is equal to 1, because if I'm picking the point 1, 1, that means x is equal to 1, y is equal to 1. Now, if that is true, then what happens is that y, I'm going to test my border. So 1 is 1 less than 1/2 times 1 plus 2. All right, and that certainly is true. So is 1 less than 1/2 times 1 plus 2? And that is true. So that means that 1 is indeed in the shaded region. That means I shaded correctly. So even before I shaded, I could have asked myself that question. Now if you look up here, if I pick the point negative 2, 2, negative 2, 2 is not going to be in the region. Why is it a negative 2, 2 is not in the region? Because if you pick the point, if you put negative 2 here for the x, 1/2 times negative 2 is negative 1. Negative 1, as we found out, negative 1 plus 2 is 1, as we noted already, right? And here's a problem with that. Negative 2 is not less than 1. So negative 2, 2 is not going to be in that region, all right? Okay? All right, so here I am. Okay. Here I am. All right. So we're going to move on to another problem, all right? We're going to move on to another problem. So we are still doing inequalities, all right? Here we go. So that was number 13. Number 13, right? Okay. All right, so let's look at the next problem. All right, actually, let's see if how Lumen is grading this. All right, so it was correct, as you can see. Let's move on to number 14. All right, so here's another inequality to graph. Y is less than negative 2x. Y is less than negative 2x. And again, what you're going to be doing is you're going to be doing the same thing that we did for the other problem, all right? You're going to be doing the same thing that you did for the other problem. Again, this is number 14 in the classwork. You're going to do your version of it. And so what happens here is that you need to come up with some points. So simply you can make a table. All right, as we saw before, this is your x, and look at your border, which is y is equal to negative 2x. That's your border. And again, this border is going to be something with a dotted line, all right? Because as you can see here, this inequality here is strict. There's no bar below, so it's going to be a dotted line. And so I can just pick 2 points if I want. Let's just pick 0. All right, negative 2 times 0 is going to be 0. And let's pick 3. All right, let's pick 3, right? So negative 2 times negative 3 is going to be negative 6. And so I got these 2 sets of coordinates that I can use, namely 0, 0, and 3, negative 6. All right, so I'm going to do that now. I'm going to take the Lumen graphing mechanism, and I'm going to draw the graph with these 2 points. All right, so I pick the point 0. First of all, I want to pick this right here, right? So I want to pick the 1 with the dotted, and I want to pick the point 0, 0, which is here in the origin. And I want to pick the point 3, negative 6, which you can see here. I have, this is going to, okay, 3, that's 3, 3, negative 6, yes. And so now what I want to do before I draw anything is, I don't want to make a decision yet. I want to ask myself, where is the shading going to be? Well, fortunately for you, it tells you here that where the shading is going to be, because it's telling us that y is less than something or y is greater than something. Let's see, it's saying y less than something. So because it's saying y is less than something, the less than sign means you're underneath the line. So we know that it's under the line. But you can pick a point to see if it's true. So here I picked negative 6. So the point I picked here is I want to test negative 6. All right, I want to test negative 6, 1, 2, 3, negative 6, 3. to see if it really is in that region. Well, that means we want y to be 3 and x to be negative 6. So let's just test it. So we have 3. Is 3 less than negative 2 times negative 6? Is 3 less than negative 2 times negative 6? Alright, so again, we're trying to find out, is 3 less than negative 2 times negative 6? Certainly. 3 is less than 12. So that means that this is indeed the correct region to shade, alright? So that is indeed the correct region to shade. And so now we can submit and to see if we're correct, alright? Alright, so indeed, we are correct. And so this is what the graph of y is less than, y is less than negative 2x. That's what it looks like, alright? Okay. So that's what the graph of y is less than negative 2x. That's what it looks like. Alright, so let's move on. Let's move on to another problem. We're going to be doing more than one inequality, of course. Soon we want to do systems of inequality. So we have it. Let's move on. Okay. So question 15. All right, so this one, so the questions are increasing in intensity, right? So here you have this question, y is equal to, negative 3y minus y is greater than or equal to negative 7. Again, negative 3x minus y is greater than or equal to negative 7. So here we have it. Come on, okay. All right, so we have something now that is not as nice looking as the other stuff that we've been working with, all right? But what we can still work with this, all right? So what you can do, you can solve for y, or you can use the method that we use in class to figure out x-intercept, y-intercept, and stuff like that, all right? So what you can do is you can make a table again, same idea. We're going to make a table. Okay. And since you have the ax plus by, so remember we spoke about this. You have ax plus by is equal to c kind of form if you ignore the inequality for now. You can kind of use that method, right? So what we're going to do is we're going to figure out what happens if x is 0. All right? So in other words, remember what we said. What we said is if you want to find the y-intercept, what you're doing is you're ignoring this. All right? So remember, you're going to be ignoring that. That's how we find the y-intercept, all right? And remember, we said that this was a, the negative 3 is a, and the negative 1 is b, and the negative 7 is c. So what's our y-intercept? Our y-intercept is always our y-intercept. All right, again, you can go and you can solve the equation in terms of y. That's also allowable, but that's not the method that we had used. I want to be consistent with what we have been using. So the y-intercept is going to be c over b, which in this case, c over b is just going to be negative 7 over negative 1. Now, if my answer came out to be a fraction, I would use a different method. All right, I would definitely use a different method. But since I got something nice, all right, so when x is 0, that is where the y-intercept happens, then y is going to be 7. All right. Okay, so now what I can do is, if I do the x-intercept is not going to be so nice because I have two prime numbers I'm working with, 3 and 7, taking the opposite of 3 and 7. So I have these two negatives of opposites of prime numbers. I don't want to use that. So what I'm going to do is In this particular case, I'm going to ask myself, what, in this case, I want to find out basically how can I get a whole number to give me -7, all right? So now, what you want to do, figure out what two negatives can give you -7. Well, one of them can be, again, this is kind of a trial and error. You can solve for the equation again, like I said before, but here, if you look at this, if you make x equal to -3, right? I mean, if you make x, rather, you can make x equal to, say, 1 if you want. You can use so many different numbers. All right, so let's just be simple. So let x be equal to 1 here. All right, let x be equal to 1. If x is equal to 1, notice what happens. I'm going to have -3 times 1. And I'm choosing integers because when you work with integers and you add and you subtract integers, your answer must be an integer. So this means that I have -3 minus y, right, is equal to 7. I'm solving for the border. So what number, if I have a -3 here, what do I need to subtract to get to -7? You should see that that's going to be equal to 4. All right, so -3, this is -3. -3 times 1 is -3. Minus 4 is going to be 7. So that's going to be 4. So y is going to be equal to 4, right? And again, you can solve and you can find it out for yourself. You could solve this and you'll still get 4. All right, and that's the point here. You still get 4. It's a -7. All right, so now you have the points that you need. You have the points that you need. You have to graph this. You have 0, 7. It's gonna be here, and then you're gonna have -3. You're gonna have 1. Sorry, you're gonna have 1 when x is 1. This is a 1 here. Y is gonna be 4, so you're gonna have 1, 4. And there you go. We have 2 points. And again, 2 points determine a line. So we're good to go, right? So now we can just go to our graphing mechanism here. All right, so it's going to take my points away. You can go to your graphing mechanism and Lumen home here that we have. And again, I'm looking for 0, 7. And again, it has to be this time. Is it a dotted line or a non-dotted line? So let's see. This time is not a dotted line because you have this. This extra bar here tells you that it's going to not be a dotted line, all right? But before I go to graph, I need to figure out something. Is the shading going to be above or is it going to be below? And so in order for us to know whether the shading is above or below, what I would suggest is that we actually do a check. So let's see, we can use the origin as a check. So here's the origin. The origin is right here, 0, 0, right? Ask yourself, in this case, I'm using the origin because this graph definitely does not go to the origin. How do I know that? Because when x is 0, y is 7. So I'm going to use the origin as a check. So in other words, I'm trying to see if I plug 0 in for x and 0 in for y, would that make a true statement? In other words, what I'm trying to say is -3, substituting a 0 here, -3 times 0 minus 0. All right, is that greater than or equal to -7? Is that greater than or equal to -7? All right, so again, is this here is a greater than or equal to sign? Let me make sure you see that. This here is a greater than or equal to sign. Is not the number 7. This number 7 is over here. That's number 7. So is -3 times 0 minus 0, is that greater than or equal to -7? In other words, is 0 greater than or equal to -7? And the answer is yes. So that means the origin is a part of your graph. So when I draw my line, I have to shade in such a way that the origin is shaded, right? So that's what we're doing here. I have to shade in such a way that the origin is shaded. All right, so let us look at that, see how that looks. All right, so here I got my graphing utility. Again, this time pick a solid line, right, because of the extra bar. And I want to look for the point 0.07, which is 5, 6, 7, 0.7, which is there. And I want to look for the point 1.4. So 1.4, 1.4 is there. And so now I make sure that wherever I graph, the origin here is covered. So the origin must be the area in which I'm shading. So I'm shading to the origin. So therefore, my graph shades down. All right. So incidentally, there are also videos below in each question. So you're getting what I'm doing here, and you're also getting what's going on in the video. All right. So of course we're correct. All right. All right, so let's move on to another question. Now we're going to be looking at number 16, which is two inequalities. We're graphing two inequalities now. Now, we did we talked about vertical lines and horizontal lines before. All right. So this right here is a vertical line. All right. So this right here is a vertical line. Okay. So this one here is associated with the vertical line x equals 6. That is the border. X equals 6 is the border or the boundary. So x equals 6 is the border for the inequality x is less than 6, less than or equal to 6. Same is a border also for x is less than 6. All right, and y is less than or equal to 2 has the border y is equal to 2. That's the border. And so what we have here is we're going to be graphing two inequalities, all right? We're graphing two inequalities. And how do you graph two inequalities? Well, you graph them, and then what's going to happen is we want to find what you call a solution. And what the solution is going to be is where the regions overlap. That's all it's going to be. Wherever the regions overlap, that's your solution. All right, so we're going to graph x is less than or equal to 6. So the first thing we need to do is to get the borders right, okay? So we need to get the borders right. So we're looking for the first border we're looking for is x is equal to 6. So again, we pick, these are less than or equal to in both cases, so we need solid lines. So you pick this, right? Now, x is less than or equal to 6. You just need one point here in the origin, and then any other point will do. Right? Perfect. And so that's it. Less than or equal to 6. That's it. And now you want to pick you're doing now y is less than or equal to 2. Incidentally, I have 2 here. That was a coincidence. And then I can pick any other point. All right. So I want to pick. Let's get the line at least first. So I want to pick here, right? And that's the red line right there. And I can pick any other point and just pick the same point here. And so it's less than or equal to, so I shade below. All right. And so that's it. And so this region here, let me use a different color, green, where they overlap, this overlapping region, I'm going to write an S in there. That's our solution. That overlapping region is our solution. That's where both of the inequalities meet, all right? So again, let me erase the border. So what we just did a while ago was we solved an inequality. So what we have here in the blue, and in fact, everything here was in the blue at the same, here too. This used to be blue, but it was covered by the other color. I'm kind of colorblind. and so the overlapping region became the solution. But anyway, so let's just write what we had. So what we had here was x is less than or equal to 6. All right, we started out here. So it started out here in this region, and it goes, everything is going over here, all the way over here. It was also down here. Everything down here was blue before. And so that's the inequality that we did. Going this way, going back, right? Going back, left, going left, x less than or equal to 6. And so now the other inequality we did was the inequality going down, right? Going down. Let me use this color. And so, actually, let me use something that you can actually see. All right, and so the inequality we did going down was this inequality, y is less than or equal to 2. Y is less than or equal to 2. That's the inequality that we just did, right? Y is less than or equal to 2. And so that inequality was everything coming from up, and this line going down, and going down this way, going down this way. And so you can see where they overlapped, right? So like I said before, in the green, that's where they overlap. So this is the overlapping region between the inequality going left, x less than or equal to 6, and the inequality going down, y is less than or equal to 2. That's overlapping region is called the solution, right? All right, so because I don't want this video to have a limit. I want to do another problem because we got to move on to the other part of the lesson today. Okay, so let's look at another problem. Let's submit it first and see if we were correct. All right, so let's clear everything. All right, so again, that was the answer to number 16. X is less than or equal to 6. Y is less than or equal to 2. That was the that's inequality right there. All right, system. This is called a system of inequalities. All right, again, it's called a system, just like a system of equations, because you have more than one equation, more than one inequality. It's called a system of inequalities. All right. Okay, so it's more than one, so it's called a system of inequalities. All right, anyway, so let's just check this and then see if we did everything right. Okay, so again, we're correct. All right, so let's move on to another inequality. All right, all right, so here is a standard system of inequalities where the inequalities are written in the form ax plus by is less than or equal to c. And over here you have ax plus by, again, is greater than or equal to c, all right? I'm going to be sending the notes to you, at least a note summary, so that you can see what goes along with this. All right, so what we have here is we have, again, the form ax plus by is what we have on the left. Ax plus by and some inequality dealing with c, right? Less than or equal to, greater than or equal to. So I'm gonna just take the first one. All right. Of course, it can be ax plus by greater than or equal to c. As we see here, it can be ax plus by less than c. It can be ax plus by greater than c. And so that's the form we have. And again, we want to find out the x-intercept and the y-intercept, all right? Using that, right? So what I'm going to do, for the sake of allowing us to see this better, I'm going to rewrite the equations down here because I'm going to be using the graphing thing, and I need to hang on that while we're working. So I have negative x. Notice that negative x is the same as negative 1x, right? Plus 2y is less than or equal to -6. And the other one is 4x plus 5y. 4x plus 5y is greater than or equal to 20. All right, awesome. And again, as we see there, both in ax plus by is less than or equal to c, or ax plus by is greater than or equal to c form. That's the form that they have, all right? So let's go to a graphing utility. So I go to my graphing utility on here on Lumen Ohm. Again, we're working on question 17. And we're gonna pick some points, all right? So you should be able to see the graphing utility on, yes. So what I wanna do here is I wanna look on what happens when, for my x-intercept and y-intercept. That's what I wanna find out, so I can graph. So for here, if I wanna find out what my x-intercept is, basically what I want is, I want for the x-intercept, I basically want to think about the a value and the c value, right? Again, you can solve by setting x equal to 0. There's a video on that. I mean, by setting y equal to 0. But all you need to remember is for the x-intercept, what you want for the x-intercept is just to take c and divide it by a. So for the x-intercept, what you have here is you're going to have c divided by a, and that's going to give you the x-intercept. So in this case, what you have is -6 divided by -1, which is just going to give you what? That's going to give you 6. So that means the x-intercept is going to be the x-intercept is going to be associated with the point 6, 0. That's your x-intercept. X equals 6, y equals 0. All right. Now, similarly, I need to erase this. I hope you catch that. Similarly, we are going to have the y-intercept by looking at what happens with the y component, which is the b. All right, so here we have it, right? So we have the c, now we have the b. And so the y-intercept is going to be b divided by c. So the y-intercept is going to be b divided by c. So the y-intercept is going to be equal to I said b divided by c, I mean c divided by b, sorry. It's going to be c divided by b, which is just going to be -6 over 2. It's just going to give you -3. All right, so what you have now is that means you have the point 0, -3. All right, so that's how you do that. And so I'm not going to go through all of this for this one. I'm going to kind of do the second one verbally because the process is the same. All right, and remember, this is a summer class. It's a lot to cover in one class. So what you're going to do now is you're going to identify your point 0, -3, which is right here. And then you're going to identify your point 6, 0, which is right out here. All right. Now for the shading, what you want to do is you want to ask yourself, again, this one is a nice one to ask yourself if the origin is there. All right. So is the origin there? So do I shade up? Do I shade down? Up or down? Well, it depends on if the origin is there. As you can see, if you look at negative x plus 2y is less than or equal to -6. If you replace the x with 0 and the y with 0, what you're going to get is 0 plus 0 less than or equal to negative 6? The answer is no. 0 plus 0 is not less than or equal to negative 6, so the origin cannot be a part of that. Again, so let's just look at what I just said. What you're asking here, right, look at this. What you're asking here is if you take, I need to use a darker marker. If you take negative, come on. If you take negative 1x, you replace the x with 0, right? Replace the x with 0, and you replace the y for the 2y with 0, right? Would it be true that this would give you something less than negative 6? Would that be true? And by far, that's not going to be true, right? That's definitely not going to be true. So that means that 0, 0 cannot be in that region, right? So 0, 0 is not in the shaded region. So that's why we refuse that. All right? Now, if you go to the second equation right here, which is, let me use a different color, which is, no. When x is negative 5, y is gonna be equal, no. This is the thing I hate about the software. Is if you make a mistake, you have to start back. You have to start over. All right, don't worry about it. So I'll go back. So again, what we have was 0, negative 3, and we have 6, 0, and the shading was down here. All right, good. All right, and so I want to check if 0, 0 was in that region. So again, I'm checking to see if the origin, if 0, 0 is in the region of that should be shaded, and we found out that it's not true, is not in the region, because 0, when you do negative 1 times 0 plus 2 times 0, we found out that it's going to give you 0, and 0 is not less than or equal to negative 6. All right, so that's not true. So this statement is false, which means the origin cannot be there. In other words, we cannot plug 0, 0 in. It's not going to give us a true statement. So therefore, the origin cannot be there. In other words, when x is 0 and y is 0, the inequality is not satisfied. All right, so let's go to the second part. Now, so the second part we are trying to graph here is 4x plus 5y is greater than or equal to 20. 4x plus 5y is greater than or equal to 20. Well, you can, again, you know your boundary is going to be solid. So you can find what the x-intercept is by just dividing, oh, sorry about that. You can find what the x-intercept is by, again, just dividing, this is c here, dividing c by a would give you the x-intercept. And what would that be? C divided by a is going to be equal to, let me use a darker color. I need to use a thicker pen. All right, so again, c divided by a for the x-intercept is going to give you 20 divided by 4, which is 5. So you have 5, 0 is going to be on this new line that we're making. Similarly, to find out the y-intercept, you're going to be doing c divided by b, right, for the y-intercepts. And again, c divided by b, as we see up here, c divided by b, just like we did previously. 20 divided by 5 is going to be 4, and so the y-intercept is going to be the 0.04. All right, so there we have it. And so now you can go ahead and you can plot. So we're looking for we're going here because we need a solid line. Why? Because we have this inequality with these extra bar below the inequality symbol, right? All right, so we look for the 0.50, which is here, and we're looking for the point 0.04, which is up here. All right. And now we ask ourselves, is the origin in this particular region? Is the origin there? And that means that if I take 0 and I put in here, let me just say, by the way, if I take 0 and I put here, 4 times 0 plus 5 times 0, is that greater than or equal to 20? And ladies and gentlemen, the answer is no. That cannot be greater than or equal to 20. So that means that the origin again here is not in the region, all right? Origin is not in the region. And again, my graph just completely messes up. That's how Lumen always, you make one mistake, you press the wrong thing, and you are gone. All right, so I understand your challenges and the homework. All right, so let me just do this over again. Perfect. And let me do this over. It was 0.4. Okay, good. And 5.0. Okay, awesome. And again, we shaded here. Awesome. And so, as I was saying, 0.0 is not in the region because we would not get a true statement. That what S that you see right there, that is going to be the solution region in this case. All right. So let's see how that works out. All right, and so okay. All right, so let's just check it to see. Okay, so we're correct. All right, so all this drawing and all your solution is in this little region right here. There it is. So that's it. All right. So it's a long, arduous process, I know, but this is how you do systems of inequalities. All right. I wish I could do more on this particular topic, but we only meet for 2 hours, and I can't make the video much longer than the time that we have for class because I have to go over this in class. I have to kind of navigate through this in class. All right, so these are your examples for your systems of linear systems of linear equations. All right. Linear inequalities, sorry, systems of linear inequalities. Okay, so that's gonna be that part for the lesson. That's gonna be it for this part for the lesson. Yep. Okay.